Hey there. Today, we're going to talk about a material you probably use every single day, maybe without even thinking about it. It's a wild story that kicks off with a complete lab accident, becomes a top secret military secret, totally changes our kitchens, and even helps us get to space. So let's dive into the incredible, accidental story of Teflon. So, to get us started, I've got a question for you. What on earth connects something as simple as frying an egg for breakfast with something as unbelievably complex as launching a mission to Mars? The answer is, well, it's probably not what you're thinking. That's right. It's that slick, nonstick coating on your frying pan. We're talking about Teflon, a material so common we just take it for granted. But it's so powerful that it works in some of the most extreme environments you can possibly imagine. But here's the kicker. This wonder material wasn't some brilliant idea cooked up in a lab on purpose. Nope. Its story begins, like so many of the greatest scientific discoveries, completely and totally by accident. So picture this. It's 1938. A chemist, Roy Plunkett, is working on refrigerants, and he's got this gas cylinder that should be full, but nothing comes out. It seems empty. Now, instead of just tossing it, he gets curious. He saws the thing open, and inside he finds this weird, waxy, super slippery white powder. Total accident. Fast forward to the 1940s, and this accidental powder becomes a top secret asset for the Manhattan Project because it could handle insanely corrosive materials. It wasn't until the 1960s that it finally hit our homes as the non-stick magic on the Happy Pan. So, what is this stuff really? Well, its scientific name is a real mouthful: polytetrafluoroethylene. Let's just call it PTFE, okay? It's what we call a synthetic polymer. Basically, it's a long chain of carbon atoms that are completely surrounded and protected by fluorine atoms. And that simple, powerful structure, that's the secret to all of its superpowers. The best way to think about it is like a suit of molecular armor. You see, the bond between carbon and fluorine is one of the strongest bonds in all of organic chemistry. It creates this nearly impenetrable shield around the carbon chain. That means almost nothing can get in to react with it, and almost nothing can stick to it. That's the secret sauce right there, what makes it so non-reactive and so non-stick. And because of that incredible property, Teflon isn't just for cooking, not even close. It has become a quiet, unsung hero in pretty much every advanced industry on the entire planet. And this is where the story just gets absolutely wild. The exact same material that keeps your pancakes from sticking to the pan is also used to line the fuel systems of rockets, where it has to handle incredibly corrosive fuel at insane temperatures. I mean, just think about that for a second. That range of performance is just unbelievable. In the world of aerospace, PTFE is absolutely critical. It can handle temperatures from a bone-chilling minus 200 degrees Celsius all the way up to a blistering 260 degrees. It's used to insulate wiring on satellites, to make seals and gaskets that just cannot fail, and to stand up to the harsh radiation of outer space. It's the very definition of reliability under extreme pressure. Then you have modern medicine, where its job is just as vital. Because PTFE is so inert, so unreactive, the human body basically just ignores it. It doesn't see it as a foreign threat, so it doesn't reject it. That makes it perfect for things like catheters and surgical tools. But even more amazing, a special version of it is used to create artificial blood vessels and other implants that literally save people's lives. And what about the device you're watching this on right now? Yeah, there's a really good chance Teflon is in there too. It's a fantastic electrical insulator, which makes it absolutely essential for the high-frequency cables and circuit boards that power our entire digital world. It helps keep all our communication signals zipping along fast and clear. I mean, the list just keeps going and going. In heavy industry, it's used to line pipes to handle the nastiest, most corrosive chemicals you can think of. It's made into self-lubricating bearings that cut down on friction. And it's even woven into high-tech fabrics that are somehow both breathable and waterproof. It's a true problem-solving material. But you know, a material this powerful, this indestructible, it doesn't come without its own set of problems. And this brings us to its really complicated legacy. First off, let's clear something really important up, because there's a ton of confusion out there. You've probably heard about health concerns with nonstick pans. Well, those concerns are almost always about a chemical called PFOA. Here's the key. PFO was a chemical used in the past to help manufacture Teflon. It's not the Teflon itself. The final product, the PTFE on the pan, is stable, inert, and non-toxic in normal use. On top of that, modern manufacturing has pretty much eliminated PFOA from the process anyway. But this brings us to the real paradox. The very properties that make Teflon so incredible, the fact that it's so stable and durable, also create a huge environmental headache. It's a forever material. It just doesn't break down in nature. And while you can recycle it, it's really difficult and takes a lot of energy. So while it's totally critical for so much of our technology, we have to face the fact that we're making something that's going to stick around for, well, forever. And that really leaves us with a final, massive question. A forever material like this gives us these unbelievable benefits. It enables technology we couldn't even dream of otherwise. But with that comes a forever responsibility. So how do we keep innovating and using these amazing materials while also managing their long-term impact on the planet? It's one of the biggest challenges at the heart of modern science and engineering.